Today's lesson, 3.1, is reading quadratic graphs. Quadratic graphs always make a parabola, and they're very realistic situations when it comes to throwing objects because of gravity and stuff like that. So check it out. Would you believe that this first graph is about the height of a ball that's thrown versus time? All good with that? What do the x values of this graph represent? Boom, right here, time in seconds. What do the y values of this graph represent? Height in feet. Height in feet. Then they ask some more serious questions. What is the initial height of the ball? Well, the initial height would be when the time is equal to how much? Like how much time has passed when you just got started? 0 seconds. So if you go to 0 seconds, do we know the initial height of the ball? 6 what? Feet. Labels are going to be the big thing. 6 feet. What is the maximum height of the ball? Maximum height of the ball is right here, 12.25 feet. Got to have the labels. How long did it take for the ball to reach its max height? It took 1.25 seconds. Does anybody know what this point is called again right here? It is the maximum, but on the parabola, that has a special name. What is that thing called? That is the vertex of the parabola. And this whole chapter, I shouldn't say the whole chapter, half of this chapter, that's a very important thing. How to find the vertex. We already did that last chapter. So what does the ordered pair 3, 0 represent in this situation? So it's all back to writing a complete sentence, and it's back to knowing what x stands for and what y stands for. If you laughed at me for having these questions on here of what x stands for and what y stands for, then I will laugh at you if you can't write the complete sentence. 3, 0. What does x stand for? What does x stand for? What does x stand for? 3. X doesn't stand for 3 seconds. What does x stand for? Time in seconds. What does this 3 in the x value stand for then? 3 what? And then what does 0 mean? 0. So we won't say that, though. It does stand for a height of 0, but we won't say that. What happens when the ball gets to a height of 0? What is that realistically? That is the ground. So what would you like this to say? Would you like this to say the ball hits the ground after 3 seconds, or would you like to say after 3 seconds the ball hits the ground? Which one of those do you feel is correct? Words. Because x comes first, we have to mention stuff about x first. So we'll say after 3 seconds the ball hits the ground. This is about x. This is about y in that case. Like I said, real short chapter, man. So this test is coming up fast. These complete sentences and these labels and all this stuff is the most important part probably. You could still get every question right, kind of, but get a C on the test just for not putting it in a complete sentence or not answering the sentence the way it's supposed to be. So after 3 seconds, the ball hit the ground. Sound cool? Always talk about x first, y second. Where on the graph was the initial height of the ball? Ashley, you were the next person on the wheel when I accidentally spun it. What is the name of this point? Not 0, 6, but not just 6. I don't. So because the graph starts on the y-axis, that is the y-intercept. The y-intercept. And then I'll go back to you, Ashley. What part of the parabola did the maximum height occur at? It happened right here. What's that thing called? That's the vertex. And then you and your neighbor see if you can figure out where the ball hit the ground at. The x-intercept. That is where it crosses the x-axis. That is the x-intercept. And this is all a setup for us to do the entire backside, which should happen pretty fast. The backside is about finding either the y-intercept, find the vertex, or find the x-intercept. Those are the basic ideas of this. Those 3 points are magic. And to preview our graphing calculator chapter, when we do this with a graphing calculator, we still need to know before we punch a lot of stuff in where the y-intercept is, where the vertex is, and where the x-intercept is going to be. Those are our important things. So we're going to find them by hand. First, for the y-intercept, it says, here's how to find the y-intercept. If I go back to this graph, would you believe that as an ordered pair, somebody is 0 for a y-intercept, who is 0 every time? X is 0. It doesn't matter if it's at 0, 6, 0, 4, 0, 3, whatever. Wherever this touches, the x value of a y-intercept is always 0. So that's why to find the y-intercept of this, you're going to let x equal 0. So check it out. A ball was thrown in the air followed by this path. Meow, 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 meow. What is the initial height of the ball? Initial height means find the y-intercept. You might maybe even make a note, if you wanted to. This is to find the initial height. Y-intercepts help you find the initial height of a ball or a thrown object or anything like that. And it's so easy that we don't even need a calculator because 0 is a very, very magical number. We're going to put 0 in for x. So I'll sub in. You don't have to. You can just watch. So I'm not putting 0 in for y, so I'm going to get y equals. I'm going to put 0 in for this. Help me mentally. What's 0 squared? 0. Times negative 16. It's like that goes away, right? That's nothing. Plus 48 times 0. How much is 48 times 0? It's nothing. It's like that goes away. And then there's 4 left. Right? Hey, what was the initial height of the ball, my friends? For what? For... I guess they don't tell us. Oh, I get those up here. X stands for time in seconds, and Y stands for height in feet. So we'll do 4 feet. That's the y-intercept, my friends. Because this parabola was in standard form, the y-intercept is this guy right here. That's the c value. Ax plus by equals c. Because when you let x equal 0, this nugget disappears, meow, and this nugget disappears. So if a rock was thrown in the air and followed this path, what is the initial height of the rock, my friends? That is what? 5 feet. Too easy, right? What you really have to understand is the initial height is the y-intercept. How do you find the y-intercept? Let x equal 0 in that case. Next, read. Find the vertex. To find the vertex of a parabola. The good news is we just kind of did that in chapter 1. If the parabola was in what's called standard form, ax squared plus bx plus c. There's also vertex form of a parabola, which could be here in green. This is like what the purple note card parabolas looked like. It was in vertex form in that case, where it had the parentheses and it was being squared and all of that cool stuff. So we have to recognize what form the quadratic is in first. Is it in standard form or if it's in vertex form? Standard form, we do the same old story. Opposite of b over 2 times a to find the x value, just like we did before, and then we sub that in to find the y value. But vertex form, bro, it's called vertex form for a reason. You could literally look at it and see what the vertex is. The vertex is always h comma k. So h comma k. H, remember, just like the purple note card, it's the opposite of what you think right here. So here's the h value. It's opposite game. Here's the k value. Talk to me. I'm just going to make some problems up. Y equals 2 times x minus 3 quantity squared plus 5. This is a parabola in vertex form. What's h? 3 or negative 3? It's 3. What's k? That's the vertex. 3, 5. You could look at it and tell me what the vertex is in that situation. This dude, y equals 2x squared plus 6x plus 11, is not in vertex form. That's standard form. You cannot look at it and see what the vertex is. You have to do some algebra. So here's our ball again. It's thrown in this path. Meow. Tell your neighbor real quick, is this in standard form or vertex form? He's in standard form, so let's go find the vertex. I don't care what these questions ask, Well, I guess I do. I do care because they say the max height and the max height and the max height. On our sketch before that we had back here, isn't the max height always happen at the vertex? So the phrase max height is very important for us to know that we need to find the vertex. So I don't care about finding x first or y first or anything like that. I'm just going to do some algebra to find the x value of the vertex. What's my little formula? Opposite of b over 2 times a. I'm going to ask nicely. I'm not going to grade this. I'm just going to ask you nicely to write that down every time when you're finding the x value of the vertex. You know as well as I do, the more you write something, the more you remember it. Right? So please, if you write that down, I'll bet you will have 10 times the success when it comes to finding the values of the vertex. Opposite of B over 2 times A. Find the x value of the vertex, or negative 32. So I'm going to punch that in because that's probably a decimal. Was it 48 over 32, right? I know they're both negative, but guess what a negative divided by a negative turns out to be? Positive, right? So I think that decimals make sense in this story situation. Instead of reducing that to 3/2, doesn't 1.5 make a lot more sense for like this time in seconds? It's like, would you rather say it took 3/2 seconds or 1.5 seconds? So that's the x value. How do you go finding the y value now? We will substitute 1.5 in for x. To find the y value, we just got to put him in parentheses. So let me minimize this so I can see what I'm supposed to be typing. Negative 16 times 1.5 squared plus 48 times 1.5 plus 4. Boom. 40. That's what I got. So I'm going to write it as a ordered pair. And now I'm going to go back and answer the questions. I read stuff about max height. I wanted to find the vertex. I found the vertex, 1.540. What is the maximum height of the ball? Is it the 1.5 or is it the 40? 40 label, feet. How long did it take? 1.5 seconds. Questions about that? I found the vertex. Why don't you and your neighbor try number 17? Realize if it's in standard form or vertex form, and if it's in standard form, do some algebra. Because they mentioned the old max height, we need to find the vertex. Correct? So I'm going to do x equals opposite of b over 2a, negative 32 over negative 32. That's 1, right, for the x value of the vertex. Sub it in. Put 1 in for x, and what did you get for that? Spinny, spinny, spinny with timeout. Spinny. Yes. So we got 21 for a y value of the vertex by punching that in, and that would be 21 feet. And how long did it take, everybody? It took how long? 1 second. Don't forget the labels. Not too bad. Those were in vertex. Excuse me. Those were in standard form. Standard form, ax squared plus bx plus c. Is this parabola right now in standard form or vertex form? Tell your neighbor. That's in vertex form. So the vertex should be h comma k. What is the vertex at? 2.5, 23, right? H, k in that case. What is the maximum height of this rock? 23 feet. How long did that take? 2.5 seconds. Like I said, not a bad day. Not a bad day at all. So far, we have found the maximum by finding the vertex, and we found the initial height by finding the y-intercepts. Now to figure out where the ball hits the ground at. It's the x-intercepts. There's a lot of ways to find the x-intercepts, guys. We got to let y equal 0. So if I could do this for a second. If you let y equal 0 on this guy right here, instead of me writing it all out, there's a lot of ways to do it. You could factor that. You could complete the square on that. You could use the quadratic formula. You could graph it with the graphing calculator and find the x-intercepts. What we're going to do today is use the quadratic formula. I wouldn't want to factor this. These numbers are too big. You got to frowny face factor this, dude. Take negative 16 times 4. That's negative 64. You'd have to find two numbers that multiply together to be negative 64 and add together to be 48, and that might not even happen. You might not even find those two numbers. So I think what we're bringing back this year is we're bringing back the quadratic formula. You have done very little of that in your math past. It's time to bring her back. Here's the hardest part about it. You got to know it. You have to memorize this quadratic formula. So let's do this. I have had way more success if students identify A, B, and C. I'm sorry that my pen's not working very nice here. Let's identify A, B, and C off to the side. A equals, come on pen, work for me. B equals, C equals. Who's A? Negative 16. Who B? 48. And C is, come on pen, work for me, work for me, work for me, is 4. Here's how I've been doing the quadratic formula since I was in 8th grade, which was a long, long time ago. 1993 was when I was in 8th grade, right? So fitting on decade day. Ever since then, since I've been 14 and now I'm 40 years old, I do the quadratic formula the same way. I have to say it to myself when I write these things down. I have these A, B's, and C's, and I literally do this, opposite of B. But I don't write opposite of B, I write negative 48. Isn't that the opposite of B? Plus or minus the square root of. Then I do B squared. I'm going to use my calculator to do that. I'm not going to punch it in on this screen because my computer's acting, so I'm going to do 48 squared by hand, and I got 2304. Did you get 2304? So I did the B squared part right here. Minus 4 times A, write it with parentheses, guys, because that's how we need to punch it in, times C, all of it over 2 times A. So I only figured out 2 things ahead of time. I figured out this, which is B squared, and 2 times A. I figured those 2 things out ahead of time. The next thing I want you to do is figure this out, the entire green thing. Forget about the radical, though. The radical has nothing to do with it. This is called the discriminant. You're going to hear lots and lots of questions about the discriminant. So let's just punch in the 2304 minus 4 times negative 16 times 4. Notice I use parentheses for all my multiplying also to make that larger for you to see. And figure this out. 2048, is that what you call it? Did I punch it in wrong? Oh, I got to do negative 16. Thank you. I made a mistake. 2304 minus 4 times negative 16 would make a difference, right? Times 4. Is that my C value? Did you get this instead, 2560? So just goes to show, we all type things in wrong. You know, it happens. So that's why I like these displays, though. You can see what you typed in. Hey, I wonder if this is a perfect square. Do you think it's a perfect square, 25? Because it doesn't have to get square rooted in this. Let's see if it's a perfect square. I'm going to square root this answer. Is that a perfect square? Nope. So that's going to be nasty town. So here's what we're going to do. These answers are going to be nasty. We're going to write down exactly what we had. The radical is still around it, but we're going to throw that discriminant underneath here, which was what again? It was 2560. So what we're going to do, this didn't come out very nice, we're going to punch this in. And it's not the easiest thing to punch in. We have to do the numerator first and then hit equals. And there's 2 answers up there because of this plus or minus. So let me do this. If I can get my calculator going on this pen, it's working very nice. Let me get this calculator going. Let's do negative 48. And let's do the plus first. Come on, calculator, work for me. Negative 48 plus the square root of 2560. I apologize for my calculator not working. I got to clear it out and start over. Negative 48 plus the square root of 2560. And hit equals, please. That's not our answer. What still needs to be done to that answer? We got to divide it by negative 32, right? So let's do that in our calculator. Divide it by negative 32. And that's going to be a really nasty decimal, and it's negative. We'll round that to 2 decimal places since it's really weird. So we're going to say about negative 0.08. About negative 0.08, one of those answers. Remember, there's going to be 2 answers. So about negative 0.08. Now we got to do the other one. An approximate in front of that. We did the plus. We got to do the minus in that case. So negative 48 minus the square root of that. And then divide it by negative 32. And then we'll get a positive answer. About 3.08, is that what y'all are getting? So there was two answers, negative 0.08 or about 3.08. One of these is probably extraneous because remember we talked about that earlier. It can't take negative 0.08 seconds for the ball to hit the ground. Shouldn't it take about 3.08 seconds in that case? So let's cross this out. I want you to put them both, but cross that out, and we'll have to say approximately 3.08 seconds. So there's just one more, baby. They want to know how long it took for this rock to hit the ground. Let's use the quadratic formula. Let's do A, B, C, and then I'll let you substitute those in. This is in standard form, so that's nice. Substitute those into the equation, into the quadratic formula. Opposite of B, it's right in front of you on your paper if you're not sure what it is. I have subbed it in. Now I'm going to clean up my discriminant. Get rid of this for you all. The 1024. This calculator is really frustrated today. Sorry to everyone for having to put up with it. Times negative 16 times 5. I got a discriminant of 1344. All over negative 32. Don't try to cancel those out. That's a tempting thing to do, but it's got to cancel out with all three things before you can do that. So 32 definitely doesn't go into the square root of 1344. We'll just punch that stuff in. So negative 32 plus the square root of 1344. World's slowest calculator enacting here. Hit equals, divide by negative 32. And we'll always get one negative answer and one positive answer when we're doing these problems where the rock starts above the ground. So about negative 0.15. What was the other one when we punched it in? Negative 32 plus the square root of this, then divided by 32? 2.15-ish? Is that what we're getting? And we'll throw out the negative, and we'll throw seconds on this one. Quadratic formula. There's not very many homework problems, so please practice it well. And then we'll do more ways to solve a quadratic next time. Carl started his own business. Oh, Carl's Cutters. I hope you find enjoyment in all the creative names I came up with all these people's businesses. So, Carl's Cutters. Guess what Carl sells at Carl's Cutters? Lawnmowers. How creative. His profit equation has followed this path. I'll talk about where this comes from in a little bit. We're going to talk more about profit next chapter, but his profit function is a parabola that opens down, where X stands for the number of lawnmowers sold and produced, and Y is his profit, how much he makes. You guys know that profit is like how much money people are making, right? Okay, good. What is the initial profit for Carl's company? Initial. Talked about it last time. Initial is which one? X-intercept, Y-intercept, or vertex? It's the Y-intercept. Can you tell by looking who the Y-intercept is? Remember you let X equal 0? So what is the initial profit for Carl's company? This number. It's negative. Bro, can profit be negative? Can companies lose money? Is that possible? Yes. So we're going to say $28,800, but we won't call it negative. We're going to say a loss. Why would Carl initially be in negative land? What happened? He's got to buy all the materials to make the lawnmowers, or just buy the lawnmowers for somebody else and then resell them. You know what I mean? It's like he has to invest some money into like all of the things he's going to sell, right? You know, so he's got to spend some money before he can make some money. You with me on that? So he started at a loss. How many mowers must Carl produce and sell to maximize his profit? When they mention maximum, do we want to find the y-intercept, the vertex, or the x-intercept? Let's do the vertex. Is this bad boy in standard form or in vertex form? Standard. So I didn't give you much room to do it, so we'll just kind of do it right here. X equals opposite of B over 2 times A. Please find the x value of the vertex. Shouldn't be negative. If you did, it's just a little write-down error or a typing error. Remember, it's the opposite of b over 2 times a. So that happens. Someone in class got a negative. It's just because we've missed a sign here or something like that. It's no big deal, right? You know, but common sense will take over and go, Carl can't sell negatives to 300 mowers or anything, right? Now, how do I find, we might as well just find the whole vertex while we're doing it, because they're going to ask us the next number if my pen would start working again. So 306 is the x value of the vertex. How do you find the y value of the vertex again? Sub it in, baby. Use parentheses. Use parentheses. So move this out of the way. Negative 4 times 306 in parentheses, quantity squared. Damn it. This calculator. So I got it all punched in parentheses, hit equals, and I heard whoa from the crowd. Whoa, this dude's selling lawnmowers. This is like his business that he wants to make, right? He's profiting in dollars. It is okay to expect a large amount right there. It's like, yeah, the maximum profit that old Carl could do is make $345,000 and 700, you know, all this stuff. So expect that when it comes to profiting. If you've never bought a lawnmower before, because I doubt many of you have bought a lawnmower before, but they ain't cheap. You know, just a push mower is $200 or $300. You know, get one of them riders, and you're talking in the thousands of dollars in that case. So we can now easily answer these questions. How many mowers must he produce? Is it the 306 or is it the big number? 306. And we'll put the label with it, mowers. And the maximum profit is $345,000 and the 744. I just kind of say it out loud. What I do want to talk about, though, before we talk about breaking even, is why the heck this makes like a parabola in the case. And I'm not an economics major by any means. You can go talk to Mr. Hibbs or whoever wants to tell you, but I know the gist of it, right? Let's say that Carl over here is making these lawnmowers, right? And have you guys, what if he just made, let's say, 2 million lawnmowers? Like, do you think he's going to make like a profit off of that, or would he probably have bought too much stuff and lose some money? What do you think? He'd bought way too much. Because it's called supply and demand, right? There's only so many people, wherever Carl's located, that need a lawnmower. You know what I'm saying? And I don't know if all of you remember, it depends on how old you are, but a few years ago, all of our computers had a stylus with it. You know, like the juniors and seniors probably remember this, that they had a stylus with it. And I know the freshman and sophomore never had that one, but had a nice stylus. But in that stylus, you needed a battery, a quadruple A. Not a single A, not a double A, not a triple A, but a quadruple A battery, right? And when that battery died, your stylus didn't work anymore. So here's what I did. I totally bought a bunch of batteries and sold them to kids for $1. You know, it's like if you needed a quadruple A, I would sell you one for $1. I bought 50 batteries, and it cost me $20. Right, $20. Could I have profited off of that situation? Yes or no? Because I sold them all for $1. Because if kids individually went to Walgreens to buy the batteries, they're like $2.50, you know, to buy the battery. But I was selling them for $1, so they're like, that's a heck of a deal. But I bought them for 50 and sold them for 20. How much could I have profited off of that situation? If I sell them all, right? How much could I have profited? $30, right? So because there was a supply, right? I had a supply, and there was a demand for them. It's like I ended up making a profit. What if I decided to buy, or first of all, why did I get them so cheap? How come I got them so cheap? I bought them in bulk, right? When you buy things in bulk, they get cheaper. So what would have happened if I would have bought, say, 5,000 batteries? Do you think I would have made money or lost money in that situation? I would have had to spend probably $2,000 to $3,000, you know, like buying those batteries in the first place. Could I have sold them all, you know? Probably not, because we got rid of those computers, and now no kids don't have the stylus anymore, and it's like I'd be sitting on all these extra batteries in that case. So this is what happens with Carl. It's like he can only make a maximum profit because of the supply and demand. Not everybody in the world needs to buy a friggin' lawnmower. You know, it's like he's only got a certain amount. So that's why all these profit equations turn out to be quadratic. I'm just going to give you a little sketch because he can start wherever. He starts in the hole, and then all of a sudden he could sell it. And then it gets to a point where he has bought too much stuff, and it's like his profit's going to start coming back down, coming back down, coming back down. So you got to do the math to figure out what's the right thing to do. Let's figure out the break-even points. We have had a hard time in college algebra figuring out what break-even means. Let's go back to my battery example. What does it mean if I broke even? Yes, ma'am. I didn't make any money, right? But I also didn't lose any money. So tell me about your profit. It was how much? If you didn't make any money and you didn't lose any money, your profit was how much? It's 0 in that case. Isn't breaking even making 0 profit in that case? So which one of these is profit? Is it X or is it Y? It's Y. We're going to put 0 in for Y into this equation up here. 0 equals negative 4x squared plus 2448x minus 28,000. And now they don't tell you how to solve this quadratic. I will give you choices. First, let's talk about GCF. There is a GCF because all of these are even numbers, but it's probably not going to help us because these numbers are huge. You know, they're ridiculously big. Even if we took a GCF out, it doesn't make them much smaller. Would you like to try to frowny face factor this, or would you rather use the quadratic formula on this one? What do you think would be better for our brains? Quadratic formula makes way more sense. I don't have to waste any time finding two numbers that multiply together to be this and add together to be that, because the numbers are ridiculously huge. It's like you spend all day doing that. So let's use the quadratic formula. Why don't you pause the video and get it set up, right? Isn't it like 5,909,000? So don't even write that long number. Just put 2448 squared minus 4 times A times C all over 2 times A. You with me on that? Then I'm going to go find in the discriminant. We will write that down. So I got this big old number for the discriminant, negative 2448 plus or minus square root of big boy 5531904 all over negative 8. So I'll go punching that in. Negative 2448 plus the square root. You can use the previous answer button if you want to, so you don't have to retype that number. Your previous answer button is right over your minus, so second answer. Hit equals and divide by negative 8. And I got 12 for one of those answers. You find the other one. Got to do the minus. 12 or something. Negative 2448 minus square root of big boy, hit equals, divide by negative 8. What are we coming up with? 600? Sound okay with that? They both came out positive. We'll see that why when we start sketching our graph. So we did all of this first to sketch our graph. Now let's go ahead and make our graph. That's what this says. Put us all on the graph. Let's label the axes. What's the X stand for? Number of lawnmowers. And doesn't Y stand for profit? So make it real nice in this situation. I'm going to go back and just kind of do it all over again. Number of lawnmowers. And this is profit over here. In dollar bills, y'all. And we're just going to take these 4 answers that we kind of have up here and make a sketch of it in this case. First, we're going to start with the y-intercept. Oh, my bad. We'll call it the initial profit. Isn't this the y-intercept in this case? It's negative, though, so we're going to go down here, put ourselves a dot of 0, negative 28,800. Carl and his little mower company here started down in negative land. Cool. Then I want to just kind of feel this out. I like these x-intercepts next. This is where he broke even. So one of them is really, really tiny, 12. That means after he sold 12 lawnmowers, he busted even again. You know, he started in the hole. He has to sell 12 lawnmowers. Now he's back to even. And then if he goes all the way over to 600 lawnmowers, it's going to break even again. So I'm going to put the 12-0 right about here. I'm going to put the 600 0 way over yonder. And then I'm going to go put his maximum pretty much right between those two. Like here's the two x-intercepts. I'm going to figure out like where right between there is. This is around the 306 mark, but I got to go up way up here and call that 306, comma 345744. Just making a rough sketch of that guy. Doesn't matter what order you put these in. I've just always kind of done that first so I can get it all balanced out because the vertex is pretty much right smack dab in the middle of that. And here's the question. Should I keep this thing going? If Carl like bought 600 lawnmowers, that was way too many, right? And he would have like spent too much money on the lawnmowers and would make no profit. Could he have bought more lawnmowers than that and actually went negative profit again in that case? What if he bought 1,000 lawnmowers? Wouldn't that put him even further in the hole? So keep this thing going down. Right? With research, with market research, is what they do in real life, you could totally see, yeah, about 300 lawnmowers is probably going to be what you need to buy, Carl. You know, it's like that's going to be your best scenario for you based on market research in that scenario. If you buy more than that, you'll have some money, but you probably won't make as much as if you just only bought around the 306 mark in that case.